Okay, let's take a few minutes to look at some basic measurements and calculations you would find yourself needing to do with a cone. And in this case, I have what's called a right cone. And the reason I bring that up is all I'm saying is it's a cone that points straight up and down while the circle is laying flat, the base is laying flat on, say, a table or something. It's not tilted or slanted to one side, because that does change things slightly in how you approach it. We're going to look at what's called a right cone, straight up and down. Now, within this problem, as we jump into what I would call the easiest of the calculations, we'll take a look at the volume calculation. What I would hope is that some of you out there would immediately recognize this portion of it. Okay, that right there is the same formula we just got done using for a cylinder. Okay. And if you think about it, this could be, you could have a cylinder that's got basically the same radius as that cone, and actually I drew that poorly. Could draw it even better with the same height. And the volume of the cone is actually 1/3 the volume of the whole cylinder. If you take the volume of the whole cylinder and you divide it by 3, you get the volume of that cone. That's why this is in that problem. So the reason I'm putting that out there is just so it might make it easier for you to remember the formula if you know where it comes from. Now to do this one, it's actually fairly simple. We have two measurements we need. We need something for the radius. In this case, our radius is 3. So let me write this in. My volume is 1/3 times pi times the radius, which in this case is 3, squared, times the height, which happens to be 4. Okay, now how you put this together is up to you. It's all multiplied, so you can kind of do it in whatever order you want. If I were doing this one, I'd probably think to myself, okay, that's 1/3 pi times 9 times 4, and that's 36/3 pi. All I did was multiply 9 and the 4 to get 36, and then I'm going to have to divide it by 3 eventually, so I'm going to get 12 pi, and this is units cubed because I'm dealing with volume. Okay, and three-dimensional volume is always in cubic units of some kind. Now the second of these, well, what I usually find is students are pretty good at figuring out volume of a cone. It's the surface area one that's a little tougher to remember and a little tougher to understand because we're throwing a new measurement in there that you don't always need in a lot of these calculations. And that new measurement is this one right here. Okay, I'm labeling with an L, but you could use any letter you want. Sometimes you'll see this written with an S or something else. But what that's called is the slant height. Okay, it's not the straight up and down height. It's the slant, like we're climbing a big hill all the way to the top. What is that distance that we'd have to follow? Okay, now, sometimes you're given this number, and sometimes you have to use the Pythagorean theorem. You have a right triangle, 3, 4, and we could find that hypotenuse by doing the Pythagorean theorem, and it would turn out to be 5 in this case. Now, to put in this formula, we have pi times the radius squared, which is still 3 squared, plus pi times the radius. Okay, that hasn't changed. And that L happens to be 5. Okay? Notice, in this case, we don't need the overall straight up and down height. It's not part of our formula, and I'll show you why here in just a minute. Now, when I put these together, let's take a look at what happens. This part here, that becomes 9 pi. This part here becomes 15 pi, and those are like terms, so I can just add those together to get 24 pi. Okay? And 24 pi would represent square units, because now we're talking about flat space, not three-dimensional space. Now let me show you just quickly here, with the time we have remaining, where this formula comes from, so maybe you can remember it a little bit easier. Let's take a look first at this portion of the formula. Let me do this in a different color. That portion right there. Okay? Pi r squared. You should recognize that. What that's showing me is what's the space that it takes to make the bottom of that cone, that big circle. Okay? Now the other part is a little tougher to visualize, but if I were to say take an ice cream cone, and I took all the stuff that makes the cone that I actually hold on to, this stuff right here, and I were to unwrap it, that's not going to be a perfect rectangle, it's not going to be a perfect triangle, it's going to be a little bit different shape. Okay? And if you think about it, unwrapping that, it really takes on the shape kind of like a circle, like you're used to. Okay, but it's not exactly the same. So let's take a look here at what would happen. This right here is pi times the radius times the slant height. Notice the actual height isn't really a part of the outside structure of this thing, so it isn't really part of the calculations. And I hope that gives you a little bit of intuition on how to approach these problems. When you see a cone problem, you're either going to be dealing with this formula or this one. Chances are there isn't much else.